Welcome back. Thank you for rejoining me for 6-2. So in part A, we talked about multiplying radical expressions together. So today, the next natural thing to discuss is dividing radical expressions. So this is going to be very similar to multiplying for the most part, okay? So when you're dividing, you want to simplify anything on the outside of the radicals, okay? So divide anything on the outside. Then you can reduce the fraction inside of the radicals. Now, what does that mean? Well, that means two things. It means dividing the numbers, and it means subtracting exponents of common variables. So when you're reducing fractions, remember that's what you're doing. You're dividing the numbers, but that means subtracting exponents, okay? And then obviously reduce using rules of radicals. And again, the really nice thing is we're assuming variables are positive. So again, just a reminder, that means no worry about absolute values, right? We don't have to worry about those if we're already assuming everything is positive. All right, so let's take a look at this. So my rule is simplify anything on the outside, which in my first example, there is nothing on the outside. And then it talks about worrying about the inside, okay? Reducing the inside of the radical. So 2 over 18, both of them are inside the radical. So 2 over 18 is going to reduce to 1 over 9. X to the 8 divided by x to the 3. Again, dividing means subtracting exponents. 8 minus 3 is going to give me an x to the 5. All right, so analysis simplify using just rules of exponents, okay? Reducing the radical. So up here, would you agree? I don't even really need that 1, correct? I could just call that square root of x to the 5. So square root of x to the 5. So how many times can 2 go into 5? So again, remember if you want that visual of making groups of 2, seeing how many times can that go into 5? Well, there's 2 groups that go in, and then there's the 1 that's left over, right? So that's how I'd simplify the top. Square root of 9, well, square root of 9 is just the number 3. And that's all you have to do. All right, so what about the next one? So again, there's nothing on the outside of the radicals to worry about, but I have some simplifying I can do on the inside of the radicals. So remember, your life becomes a whole lot simpler if you actually do that division first. So 162 divided by 3. That's going to give me 54. And then subtract exponents. 5 or y to the 5 divided by y to the 2 is y to the 3. Okay, you subtract your exponents. And now if you notice, this becomes a much simpler problem when you look at it this way. So cube root of 54. So cube root, let's go look at my list. Cube root, 54 is not on it. However, a number that divides 54 is 27 evenly divides 54. It's 27 times 2. So that's how I'm going to break this up, okay? I'm going to break this up as cube root of 27 and cube root of 2. All right? So I break those up because the cube root of 27 is just the number 3, and then 2 just can't break free at all. For variables, how many times can that index of 3 go into the exponent of 3? Well, 3 goes into 3 once, so I just get a y to the 1 on the outside. All right. And for the next one, so here we're seeing some things on the outside, correct? So remember the first rule is simplify anything on the outside. So here, 9 divided by 3 is 3. And then it said reduce the inside, okay? So 50 divided by 2, 50 divided by 2 is 25. X to the 2 divided by x to the 6. So subtracting exponents, well, that's going to leave 4 on the bottom. Y to the 9 divided by y, that's going to leave me a y to the 8. All right, so again, reduce everything possible on the outside, then reduce everything possible on the inside, and your life is going to become a whole lot easier. Let me show you why. So we have that 3. Square root of 25 is just 5. Then square root of y to the 8. How many times can 2 go into 8? Well, 2 goes into 8 4 times. Then on the bottom, square root of x to the 4. How many times can 2 go into 4? Well, twice. Last thing to kind of clean this up, 3 times 5 is going to give me 15. So I'll have 15y to the 4 divided by x squared. I'm sorry, maybe I should have boxed that so you can recognize that as the answer. All right, so honestly, not that horrible, right? As long as you remember, reduce outside first, so, simplify outside, simplify inside, then deal with the radical piece. So in all of those examples, right, it turned out rather nicely, okay? Now, something that I hope you remember from exponential algebra is rationalizing the denominator. So the idea that we don't want any radicals down in the bottom of the fraction, okay? That's deemed as improper, okay? So part of what we need to do is know how to clean that up. Okay, and of course it's going to be a little bit more difficult than an expo because we're dealing with higher power things, right? We're not dealing with just square roots, we're dealing with cube roots and fourth roots and things like that as well. So let's talk about some steps we can take. What can we do if we do end up with something in the denominator? Step 1 is, again, always reduce first, okay? Reduce a fraction first before you ever worry about the radical. Your life is going to be so much easier if you do it that way. Then for the number and each variable in the denominator, identify how many of each are missing to make the radical complete, or having n of them, okay? I'll get to that in just a moment. And then obviously at the end, multiply top and bottom by the of the fraction by those missing pieces and simplify. So let me show you exactly what I mean by that, okay? So what I mean is the fourth root of 2 divided by the fourth root of 3. So of course, first thing to worry about is, can I reduce the fraction? So 2 over 3, no, I can't do anything with that. There's no reducing to be had. So now what I need to worry about is, how can I clean up the bottom, okay? Because I have a radical on the bottom that didn't simplify out. So the way that we do this is we have to complete the bottom, okay? And what I mean by complete the bottom is, that is a fourth root, okay? So for a fourth root, to complete it, I need 4 of the same thing, right? So now I have a 3 down there, okay? To complete that, I'm going to need 3 more 3's, right? Because that would give me 4 of them in the denominator. All right, now, obviously I can't just decide to complete the bottom. So that's why in the directions it said you have to be ready to multiply the top and the bottom by that, okay? So once you figure out what it's going to take to complete the bottom, you have to multiply it top and bottom, okay? You have to multiply both. So let's see what happens. So on top, fourth root of 2 times the fourth root of 3 cubed. Well, 3 cubed is just 27 times 2. So on top, we get the fourth root of 54. And on the bottom, 3 to the third times 3 is going to give me 81. So I want you to note that 81, okay? Notice on this powers chart, fourth root of 81 is just 3. So that's the whole reason that we did this, right? Because that bottom piece is always going to work out nicely. So the way that I tell my students to think about this is on the bottom, after you complete that piece on the bottom, that actually is just free from the radical, okay? So remember, that's the whole point, completing it to break it free. So I've completed the 3. So now the 3 gets to be free of the radical down on the bottom. And that's it. And the nice thing is, if you remember to reduce first, whatever you get here won't have to be simplified or reduced any further, okay? As long as you remember to do it at the beginning, all right? So let's see this a couple more times to make sure that we get comfortable with it. So when I say make sure you reduce first, what I'm talking about is, look at the next example. Cube root of 14x divided by the cube root of 10y squared. 14 over 10, well, 14 over 10 can reduce to 7 over 5. All right, so make sure you do that first, okay? Make sure you reduce that piece, okay? And now that it is, now I have to look at the denominator because I have some things in the denominator, okay? I have some radicals down there that I need to complete so I can set them free. So let's take a look. So I have a 5 right now, but because I'm dealing with a cube root, it means I need 2 more 5s before I can break that 5 free, okay? So I need 2 more 5s, and then for the y, well, the y is already squared, okay? So since there's already 2 of them there, for the y, I actually only need 1 more to set the y free. And of course, you need to make sure that you're multiplying same thing top and bottom, so you're only multiplying by 1. We only want to change the way this thing looks, not the value of this thing. All right, so on top, what am I getting on top? Well, 7 times 5 squared, or 7 times 25, will give me 175. Then I have an x and a y up top. Down on the bottom, okay, down on the bottom, I need to think about, all right, what did I set free? Well, I completed the 5, and I completed the y down there. And so those are the 2 pieces that I can ultimately break free because now they are complete. Now, some of you may be wondering, well, isn't there more simplifying that I can do? Because I can take 175 and divide it by 5, or the y divided by y. Be very careful. This is actually simplified as you can get. Because the 5y is outside the radical, everything else is inside the radical. So remember, that's why you don't keep reducing. Because you can't simplify things where some is on the outside, some is on the inside. You can't reduce those together, okay? So that's why this is actually already done, all right? Because you can't blend outside and inside things together. All right, So let's keep experimenting with this. Again, the best way to get good at this is just seeing several examples before, so you can feel comfortable with it. For our next example, cube root of 5x squared, and then cube root of 6y squared z. Looking at that, 5 and 6 don't reduce, and then none of the variables can as well. So that means I just have to start looking at, all right, how can I complete those things that are stuck in the denominator? So for the 6, I have a 6 down there, but because it's a cube root, I'm going to need 2 more 6's. So I need a 6 squared. For the y is already squared. So to complete it, to get it up to 3, I only need 1 more y. Then the z, there's only one z down there. And again, to complete a cube means I need 2 more. So I need a z squared in there. All right, so to finish this off, now let's combine everything on top. So 5 times 6 squared, or 5 times 36, is 180. Then I have an x squared up there, a y, and a z squared up there. On the bottom, I need to look at what did I set free? Well, I set the 6 free. I completed that. I completed the y, and I completed the z. All right, and so that ends up being your answer. Again, if you reduce first, what you end up with won't be able to be reduced, okay? And again, resist the temptation of reducing anything at this point, because now you have things on the outside, things on the inside. Remember, those can't reduce together. All right, so I have to leave it just as it is. This next one I like because it actually has a little bit of a trick before we get going on it. Okay, and the trick to this one is it doesn't reduce. Okay, it doesn't reduce. However, I want you to look at the 8. Okay, so the 8 is kind of neat because isn't 8 actually the same thing as 2 cubed? So I'm actually going to take that 8 and I'm going to write it as 2 cubed. Okay? And again, this is going to help me because now I'm not going to have to reduce it later if I recognize that right away, that the number 8 can be written as a power of another number, as 2 cubed. Because now let's see what happens. So what do I need to complete that 2 now? Okay, my focus is in the 8. I rewrote it as a 2. So how many to complete to have 5 of them? I need 2 more. So I need 2 squared. I need 2 more 2's. And for the y, I already have 2 of them, but I need 5 total. So I'm going to need 3 more of those y's. Once you recognize that, now let's put the top together. So 7 times 4 is 28. Then I have x and y cubed. On the bottom, I completed a 2 and I completed a y down on the bottom. And so that becomes my final answer. All right, and then of course, what happens when I have something that looks like that? Okay, and again, this is why my biggest piece of advice is make sure that you're reducing first. Your life is going to become so much better if you reduce first, okay? So the 7 and the 2 can't reduce, but y over y squared. So y over y squared is just going to leave me with an x on the bottom. Y squared over y squared, well, something same over same, that's just actually going to cancel out altogether. And then z to the 4 divided by z squared, 4 minus 2, is just going to leave me a z squared on top. So here is actually very much to your benefit to reduce that first. Look at how much nicer this is now than with what I started with. So that's why I urge you, reduce first, because look at how much nicer of a thing I'm working with now. Now I do still have an issue because I do still have a radical in the denominator. So let's make sure that we clean that up a little bit, okay? So I need to complete the 2. I have a 2 down there, but to complete a cube root, I need 3 total. So I'm going to need 2 more 2's, and I'm actually going to need 2 more x's. All right, so I'm going to give myself that. And then let's merge the top together. So 7 times 4 is 28. Then I have an x squared and a z squared. On the bottom, I completed a 2 and I completed an x. And so that becomes my final answer. But again, look at how much nicer it became once I reduced it first, okay? So please, please, please remember to do that. Otherwise, you're going to be in for a headache if you try to just start dealing with the radical right away. All right, and let's throw in a geometry example to this. So the following rectangle has a side length of 3 cubes of 3 and an area of 9 cube roots of 7. What is its width? All right, so remember, area is length times width. So if I want the width, that means I have to divide that length over. So the width is going to be the, the area divided by the length. All right? And so if you look, I can't reduce anything yet because the 9 and the 3 can't reduce because the 9 is on the outside of the radical, and the 3 is on the inside. The 7/3 just by nature can't reduce because it's a 3 and a 7. So there's no reducing that can be done here. So the only thing I need to worry about is getting rid of that radical on the bottom. All right, so how can I complete that 3? So for a cube, I need 3 of the same thing. So what that means is I need 2 more 3's. And of course, I need a top and bottom because otherwise I'd be changing the value of this fraction. So what does that leave me? Well, on top, the 9, again, stays separate. And then 7 times 9 is going to give me 63. On the bottom, I broke free, or I completed the 3. So the 3 gets to break itself free. And finally, now, if you notice this time, I have 2 numbers outside of the radical, 9 and 3. So this time, actually, 9 divided by 3, because they're both outside the radical, I actually can reduce that to a 3. And then that is going to be my final answer. All right, so once again, of course, thank you for joining me for this. I know this one got a little bit long, but there's a lot of good stuff. All right, so please make sure in that summary, write down some notes that will help you remember what I just went through. Some of the key things that you know are going to be important to remember so you can do them on your test and the worksheet to practice. So once you do that, then just make sure you come back tomorrow ready to do your practice work.